This project built a complete GitOps platform on local Kubernetes using K3, ArgoCD, Kustomize, and modern cloud-native tools. The repository is organized with a production-style structure, separating infrastructure and application layers for better scalability and maintainability. ArgoCD is used as the GitOps control plane to automatically sync infrastructure and applications from GitHub into the Kubernetes cluster. The platform includes essential components such as Ingress Engineers, Search Manager, external DNS, and Prometheus Grafana monitoring. A fully automated setup script allows the entire environment to be deployed in minutes, making the project easy to run locally while still following real enterprise Kubernetes architecture pattern. This project is ideal for learning GitOps, platform engineering, Kubernetes operation, and modern DevOps workflow in a practical, hands-on way. GitOps flow overview. This project demonstrates a complete GitOps workflow using Kubernetes, ArgoCD, and GitHub in a production-style local environment. The workflow starts when a developer pushes infrastructure or application change to the Git repository. Git becomes the single source of truth for the entire platform. ArgoCD continuously monitors the repository and automatically synchronizes on Kubernetes manifest into the cluster. The platform root application acts as the main entry point and deploy core infrastructure components such as Ingress Engineers, Search Manager, external DNS, Prometheus, and Grafana. After the infrastructure is ready, applications like the demo app are deployed through Kubernetes manifest managed by Kustomize. The platform also enables automated reconciliation through autosync, automatically apply change from Git, self-help, restore resource if manually modified, from remove resource deleted from Git, rip detection, keeps the cluster consistent with Git. This approach creates a fully automated, reproducible, and scalable Kubernetes platform while still running entirely on a local machine. It closely follows real enterprise GitOps and platform engineering practice. Repository structure overview. This project uses a clean and modular repository structure to organize infrastructure and application resources in a scalable GitOps architecture. The repository is divided into several main directories. Bootstrap folder contains the root ArgoCD application used to bootstrap the entire platform. This is the entry point of the GitOps workflow. Infrastructure folder store on core platform components such as Ingress Engineers, Search Manager, external DNS, and monitoring. Each component has its own directory with Kubernetes manifest and customized configuration. Applications folder contain application workload deployed into the cluster. In this project, a demo application is included with deployment, service, and Ingress resources. Script folder include automation scripts such as setup.ha, which create the local K3D cluster and install ArgoCD automatically. The structure follows GitOps and platform engineering best practice by separating infrastructure from applications. This makes the platform easier to maintain, extend, and scale in future environments such as multi-cluster or cloud-based Kubernetes deployment. ArgoCD application tree overview. This project uses the app pattern in ArgoCD to organize and manage the Kubernetes platform in a shorter way. At the top level, the platform root application acts as the parent application. It points to the infrastructure directory in the Git repository and becomes the central controller for the entire platform. Application tree looks like this. Each child application manages a specific infrastructure component independently. For example, Ingress Engineers handle external traffic routing. Submanager manage TLS certificate. External DNS manage DNS integration. Monitoring deploy Prometheus and Grafana. This structure makes the platform modular, scalable, and easier to maintain. ArgoCD continuously monitors all applications and automatically synchronizes them with the Git repository. The application tree also improves visibility because developers can clearly see the relationship between the platform root and its infrastructure service directly inside the ArgoCD dashboard. With the Kubernetes cluster K3D local, this project uses K3D to create a lightweight local Kubernetes cluster for running the entire GitOps platform. K3D is a tool that runs K3 Kubernetes cluster inside Docker, making it fast, simple, and resources efficient. The local cluster acts as the main environment where ArgoCD infrastructure service and applications are deployed. Even though the platform runs locally, the architecture flow real enterprise Kubernetes practice. The cluster is automatically created using the setup.ha script. This configuration exposes HTTP and HTTPS traffic from the Kubernetes load balancer to the local machine. Using K3D provides several advantages: fast Kubernetes setup, low resource usage, easy local deployment, Russian-style Kubernetes experiences, simple integration with Docker and ArgoCD. With this approach, developers can practice GitOps Kubernetes operation and platform engineering will flow locally before moving to cloud environments such as Amazon EKS. Access endpoint. This project is posed on a major service through local endpoints, allowing developers to access the GitOps platform directly from the browser. The demo application is exposed through Ingress Engineers using a local domain powered by IP.io. This simulates real daemon-based routing in Kubernetes without requiring a public DNS provider. The ArgoCD dashboard is accessible locally through post forwarding. This interface allows users to monitor applications, view sync setup, and manage the GitOps workflow. Grafana is also available locally for monitoring on ops and observability. After post forwarding, Grafana can be accessed as localhost 3000. This local endpoint provides a complete deployment and testing environment that closely resembles real enterprise Kubernetes platform. Demo flow. This demo shows how a complete GitOps platform works locally using Kubernetes, ArgoCD, and GitHub style workflow. Step 1. Prepare the repository. The demo uses two repositories. First, application repository contains the application source code. Next, platform repository contains Kubernetes manifest, infrastructure configuration, and ArgoCD application. This separation follows real GitOps and platform engineering practice. Step 2. Deploy the platform. First, move into the platform repository and run the setup script. The script automatically creates the local K3D Kubernetes cluster. Install ArgoCD. Deploy the GitOps control plane. After that, the root app YAML file tells ArgoCD to synchronize the infrastructure from the Git repository. ArgoCD then deploy Ingress Engineers Search Manager, external DNS monitoring start. Step 3. Access the platform. Once synchronization is complete, the demo application becomes available at demo and IP.io 8080. The ArgoCD dashboard can be accessed at localhost 1990. Inside the dashboard, user can monitor application status, synchronization, and infrastructure health. Step 4. Monitoring with Grafana. The monitoring stats include Prometheus and Grafana. To access Grafana, run the Kubernetes forward command. Grafana dashboard. Open localhost 3000. This allows users to visualize cluster metrics, application health, and Kubernetes resources in real time. Conclusion: this demo provides a complete local GitOps experiences, including Kubernetes platform deployment, automated GitOps synchronization, infrastructure management with ArgoCD, application deployment, monitoring, and observability. Even though everything runs locally, the architecture closely follow real enterprise Kubernetes and platform engineering workflow.